Let's say this is you, and let's say it's a nice day outside. We've got a sun shining. Let's say it's about 70 degrees outside, and let's say you've been doing a bunch of exercise. One thing that's going to happen when you do exercise is your body's going to produce a lot of heat. And the reason for that is you have muscles like this quadriceps in your leg and like your heart that are going to be very active when you're doing exercise, and all the reactions that make them active end up releasing heat. And so a problem that your body might face in this situation is how does it maintain its core body temperature of 98.6 degrees Fahrenheit? Now, one of the ways that your body can get rid of this excess heat produced by your muscles is to sweat. But there's another way that it gets rid of heat that I'd like to talk about here, and that way also involves the skin. And so to find out more about it, let's look at a zoomed in picture of a little piece of your skin. So here we're going to draw your skin in this zoomed in frame here. So here is the surface of your skin, which we'll draw in pink, because skin is pink. And below your skin, a little bit deeper, you're going to have some blood vessels. Let's say this is maybe an arteriole. Let's call it an arteriole. And this arteriole will be supplying your skin with blood and with oxygen via the blood. And the way it's going to do this is to send off little capillary beds into the skin, which I'll try to draw here. Here are our little capillary beds. And these capillary beds, of course, consist of very fine blood vessels with high surface area that allow exchange of oxygen between the blood and the tissue. But what you have to realize about the skin for our purposes is that it kind of acts as insulation. And the reason for this is that oftentimes it's not a nice day out, and oftentimes you're not doing exercise. So when it's a cold day out and you're maybe just sitting outside, you don't want to lose too much heat. And so in those cases, it's great to have this insulation that keeps the heat from down below and from this arteriole, for instance, that keeps that heat from diffusing out too quickly. So it's really just like your house, which during winter you want to have insulation to prevent loss of heat. But these little capillaries that go to the surface of the skin, as you can tell, they kind of bypass all this insulation, and they go right to the surface. And so the heat from the blood going to these capillaries will have a much easier time of getting out. And an analogy to the house is that these little capillaries are like little windows that allow heat out past the insulation in the walls of your house. So one thing you're going to do when you're trying to get rid of heat, so now we're no longer talking about winter, is, well, what would you do in your house if it were really hot inside the house and you had these windows that were just kind of, not open too wide? What you would do if you were feeling really hot in your house is you'd open up those windows wider. So that is exactly what your body is going to do when your body is overheating. So here we've got our skin again, and here we've got our arteriole running through the deeper part of the skin. What your body is going to do is it's going to open up that window wider. And so it's going to dilate these capillaries over here. It's going to make them much wider than they were. And this is known as vasodilation. Vasodilation. It'll vasodilate those capillaries, because what's going to happen when these capillaries are vasodilated? Do you think that more or less blood is going to be passing through these capillaries in this situation or in this one? And obviously more is going to pass the capillaries in this situation. So here I'm just drawing in the insulation of our skin again. And now in this case we have a lot more blood going up into these capillaries, and therefore a lot more loss of heat to these surroundings. And so this is what happens when it's hot out and when your body wants to get rid of heat so that it can maintain its nice core temperature of 98.6. And by the way, something we should ask is, what's so special about this 98.6? Why do we want that temperature? And the answer is that your body has, as you know, tons of chemical reactions occurring all the time. And if you've taken some chemistry, you might have learned that temperature affects the way that reactions are carried out, how fast they're carried out, where the equilibrium is, etc. And that might sound, fancy or confusing if you don't know much chemistry, but the point is that all the machinery and all the chemistry of your body works optimally at this temperature, and that's why you want to maintain it. Now, this is what happens when it's hot out, and when it's cold out, what do you think is going to happen? Well, when it's cold out, you're going to want to close the windows. You're going to want to close these windows that allow heat out, so you're going to do the reverse. You're going to make your capillaries as small as possible. And so as a result, you're going to have less heat at the surface of your skin. And that's why if it's a cold day outside and you walk around, when you feel your hands, they feel extremely cold. And that's because your body has made all the capillaries in your skin as thin as possible so that you lose very little heat. And because they're thin, this whole surface area of your skin becomes very cold. Now, as a kind of review, we can also ask the question, maybe this has been bothering you for the whole video so far, but how does your body regulate the size of these vessels? And the answer is that all these blood vessels have little bits of smooth muscle around them, which I'll just draw in orange. Little smooth muscle cells around them. And these smooth muscle cells, when they contract, when they squeeze, they make the vessels smaller. And when they relax, they allow the vessels to be bigger. And the way that your body tells these smooth muscle cells to squeeze or not to squeeze is just through nerves. So I'm going to draw a nerve in purple. And it might be kind of hard to see, but I think you get the point. Your body literally sends impulses through these nerves that tell these smooth muscle cells whether they should be contracting or whether they should be relaxing.